I'm not sure whether this. Okay, then. So we had seen, let us summarize what we saw in the last class. Okay, we will have that kind of warm up, you can say. We'll go through. As we discussed that manufacturing, right? What is manufacturing in technical terms and in simple terms? So basically, conversion of raw material into finished goods, if you want to give a simple definition, or you could even say it like making of the goods and articles to satisfy the needs of mankind, right? So changing of the form or dimensions, this is another way to see it. And we saw the classification, right? This is one way to classify. That one is the material modifying processes, right? One category, other is the joining processes. So the material being modified, either the properties being modified or the shape, right? When the property is being modified, you do it through heat treatment or surface treatment, right? The microstructure will change because those uh, microstructures etc are required to satisfy some properties like strength. We need some strength, we need ductility in some cases, right? So to have those properties, you have to undergo these treatments. I mean, make them undergo these treatments. Shape modifying, we saw material removal, material addition, material retention, right? And joining processes, either permanent, non-permanent, or semi-permanent. Basically, welding is one, you can say welding, brazing, soldering, right? Another classification you could say material removal, one thing. Second one, deforming or shaping of material. Either you are trying to deform it or shape it. Shaping in the sense casting, right? That's what we mean. Deforming, that comes under the forming category. And joining, welding, as I said, right? Welding, brazing. So this is another way of classifying it. There are many ways to classify actually based on the material being processed, right? Like processes which are able to uh, what do you call, take up higher melting point materials, right? So based on material, based on technology, right? Based on the amount of material being removed, if it is removed, if it is being deformed, that surface finish, right? All these are factors. So we can make a lot of classifications, but this is a very simple one, right? For your understanding. In removing material, you can have all these processes we have under removing. In sawing, drilling, milling, turning, abrasive finishing, these all what do you call, encompass removal of material, right? Deforming or shaping, you have casting, rolling, forging, extrusion, drawing, sheet metal forming, and powder metal process, basically additive manufacturing. And joining, as I said, welding, brazing, soldering, these are most common. Adhesive bonding, this is mostly in automotive or aerospace applications. Fastening, right? Threads and bolts, either temporary kind of fastening or semi-permanent like rivets. So this is what we saw in the last class, right? Now we're going to start with the first unit, right? I have already, let me share it again, the syllabus. The first unit is about casting. Right? That's your first unit, right? So completely deals with casting, what all types of casting we have, and what all you need for a casting, like the steps involved, advantages, applications, patterns, types of patterns, materials used for patterns, right? Methods of melting, crucible and cupola operation, basically to melt the metal, right? Or the material, whichever is being casted. Defects, and then as I said, processes, the different types, the most general used, and then the gating and riser design, right? All these is what your first unit is. So let us start with that casting part. right? That's your first unit. The other parts are your forming, right? This is mostly your three units, I believe, that covers. Extrusion is forming, I mean, comes under forming. Your forging also comes under forming. And what else do we have? All those other third unit also has some forming processes. Okay, so let's see casting first. Okay, you see, casting process is the earliest to be introduced. Okay, like 2000 BC or something, we humans have been using this casting process to form materials. So this is the earliest metal shaping technique, and basically what it does is we are pouring molten metal into a refractory mold cavity, right? We have a sorry, you have a hollow cavity, right? That's what we call a mold cavity. So we're pouring molten metal into that cavity and then allowing it to solidify, right? So it's a time-based process, and that solidified object is taken out from the mold either by breaking or taking the mold apart, right? Once that is solidified, that object which is solidified, we're taking it out from the mold, right? Either the breaking the mold altogether or removing that pins, etc., what we have put. Solidified object is called casting, right? Technique followed is known as casting process. That is the general overview of casting. So if we see the basic steps that we follow in casting, we have let me show you that diagram first, right? You'll understand better, right? This is what is a sand molding process, right? So you can use sand, or there are other methods also, as we have seen, right? Investment casting, all those other types of casting, it doesn't involve sand as a major element. But when it comes to sand molding, right, you have sand as a major constraint. So these, all this light green what you're seeing is sand. Okay, so this top part is called cope. Okay, the total entity is divided into two parts. The top half is called cope, the bottom is called drag. You can see here, cope and drag, two halves. And that is the mold cavity. Okay, this exactly is our mold cavity. All these others are supporting us to have this filled with molten metal. The total setup is called gating system. Okay, starts with here, you have a sprue, you can see here, right? All these are, we'll see what all those components are and what are the functions. But just to give you an idea, with this diagram, okay, and this, what you're seeing, core, is used for making hollow entities. If you don't want if you want internal features, for example, right, wherein you don't want the material to be filled, so you place a core there, and that core will be taking up space, and molten metal will be filled around that core, right? So that you can have that feature whatever you are trying to give. And there are many core materials, we'll see that. That also covers your syllabus. You do have in that syllabus the different types of core materials, right, and when to use them. Any doubt so far? You can ask in between also. You can either put it in the chat box or unmute your mic. Okay. So you see, now you'll be able to understand better these basic steps once we have gone through that diagram. And that mold cavity, okay, is made with the help of a pattern. Okay, the pattern is exactly the object that you want as a casting. Okay, you can call it as a replica. Okay, the exact copy of the object that you want to cast. So that pattern will be placed, okay, and then we'll pour the sand. Okay, and then that pattern will be removed before pouring this molten metal. So that's the first step, placing the pattern in sand to create a mold. And we'll see a video also that will clarify these steps. You have to place that pattern in the sand, right, to create a mold. Incorporate the pattern and sand in a gating system, right? The gating system will also be made, and then you remove the pattern. Okay, basically you will ram it, okay, so that the sand is in place, right? It doesn't, there is no losing, what do you call, it will not loosen, right? You have to have certain properties. We'll see those molding properties that are required. The molding sand has to have some properties, right? For example, the molten metal is being poured, the sand should not erode, isn't it? It has to have some strength, it has to have some uh, what do you call, capability to leak the gases, okay, because it's a molten metal. So all those properties are required in the molding sand. So once we remove the pattern, then we fill the mold cavity with molten metal. Which metal is melted in the process? It depends. For example, you want to cast aluminum, then that is what you're going to melt, isn't it? If it is metal that you want to cast, and particularly aluminum, then you will melt aluminum, and then that you will pour it, right? Is that what your question was, or okay? So right, so it depends on which material you want to cast, you'll you'll melt it, isn't it? So filling the mold cavity with the molten metal, and then next allowing the metal to cool. That liquid metal will now be allowed to cool, and then break away the sand mold and remove the casting, right? Once that is solidified, after a specified time, you'll break this sand mold, right? You see a 3D diagram. That top part is your cope, this bottom one is your drag, okay, and this light brown what you're seeing, or even this one, is your sand, molding sand. This is your core, right? You see here, we want a hollow product, right? We don't want material to come in here, that molten metal to come in here. It has to be hollow, this component. So we have placed this core with the help of what? You see those silver kind of object there? That is a chaplet. It is it helps the core to stay in place. Okay, and all that gating system I talked about, right? That will help this molten metal to flow through the molten cavity, right? So we'll see what are their functions, but I want you to understand what this consists of. You have this parting line, okay? So this the line where the scope and drag meets is called a parting line. Okay, you might have observed on different plastic components you have a line in between, right? Exactly in the middle. So that is what is the parting line. Okay, and that the sand which is being held, I mean that container is called flask, wherein you are putting this sand. Okay, now let us see that video first, and then we'll see this terminology, right? After cooling, how the core is removed. You see, either you break it, right, as we discussed here, either you break it or remove the casting, right? For example, it depends. If it is to be totally uh, destroyed, then that's called this breaking away of the sand mold. Otherwise, if you have made some provisions to remove the casting, right, keeping that sand mold intact, then you can do that also. So even if you don't remove the core, you see, once you have taken out that component, that core can be removed, right, by hammering, or right. So that is how the core will be removed. Okay, now let us see that video. It's quite a long video, but we'll try to fast forward. Please confirm if you are able to see the video and hear the audio. Able to hear it, right? Audio and video both are good. Okay, so let us have a look at that. Sand casting. This is sand casting. Okay, don't confuse it to be just casting. As I said, there are various types of castings we have: die casting, investment casting, shell casting. This is your sand casting, I mean sand mold kind of casting, wherein you're using sand, right, to cast a particular material.
I guess there's a lot of people, when they were younger,
Right, this
went
is
to the
what
beach and made sandcastles. First of all, you need a bucket. And the first thing you do after mum and dad have bought you that is run onto the beach and try and make a sandcastle as quickly as you can. When you first go on the beach, you're up a long way from where the sea has been, and the sand is very dry. It doesn't really make very good sandcastles because it just pours almost like a liquid. So after a while you run down by the sea where the waves are coming up and you try again, but that sand is too wet and you find that it sticks to the side of the bucket. But between the two sides of the beach, you'll find the sand that's just right, where it's bound together with.
you see there are various kinds of sand that we use depending on the properties that are required. Okay, because different materials have different chemical processes going on, right, when we melt. So as they are solidifying, there will be a lot of gases released, there might be chances of reactions, etc. So all those, considering all those, the sand will be selected, right? There are various kinds of sands. So it's talking about the different types of sands that are available. Okay, you see that the bottom part is your drag, the top part is scope, right, if I'm not wrong, right? Top part is scope and bottom is drag. So you see, and those are called pins, locating pins, just so that this casting, which what we are doing, is aligned. Okay, the top and bottom parts are aligned, so those locating pins will help us, okay, to match the cope and drag.
In a metal box known as a flask. This is a two-part box which has locating pins so that they can be taken apart and locate accurately each time. The top is known as the cope, the bottom is known as the drag. Today we're going to make two products. The first one is a small cylinder or bearing block, and we'll use sand molding to produce that. The second product,
Right, that component is what is being made. You see, you can see that hollow feature there, right? There is a hole going through, so that we can make with the help of that core we talked about.
is a small coin, a supermarket trolley, so that you don't have to leave your pound in at the supermarket. To make a simple object, such as this little number plate, it's quite easy to just make it as a one-part pattern which can easily be produced and removed from the sand.
This is going to make three components actually.
Cylinder, once you've buried it in the sand, you wouldn't be able to remove it without breaking the sand, or if you were trying to draw it out vertically, it would break the mould unless you put a taper on it, and then you wouldn't have a cylinder. This can be overcome by splitting the pattern into two parts so that you mould the two parts separately and they locate together using pins in the.
Right, so that just as the cope and drag, you have top and bottom halves, the pattern will also be made into two halves. Okay,
Same way that the pins locate the boxes in the flask. We've already thought about using a split pattern so that you can take the two halves separately. But how can we produce the hole through the middle without having to drill it out? In industry, obviously producing something and having to machine a lot of the metal away is time consuming and cost consuming. So producing it with the hole already in place is an advantage. So we're going to use a pattern
Right, as I said, you could have, as he was explaining, we could just make a solid casting and then you can drill a hole, right, through machining. We have CNCs, we have lathes, but that is one way to do it. As I said, to produce a component, there are a lot of ways that you can use. But to look at the optimal processes that we have, if we can have this core, what he's showing, then we can produce an internal feature, right, in just one process instead of having two processes, instead of having to send to CNC or somewhere else. So to reduce the processes, they're using core so that the internal feature can also be generated.
Again, it's a split pattern, but it forms together to produce the outside shape. But it has these locating bosses on the ends, which are known as core prints. They're painted black because that's a visual clue to the people in the foundry that they know they've got to add a core to the mould. So if we take the cope off the top of the flask and set that to one side and turn over the drag, we often refer to that as an inverted drag.
Now you carefully see these are now that is the basic steps that you have to perform, right? Using that drag, and then he'll place the pattern, right? Observe carefully.
And add the first part of the pattern. One side has locating pins, so it sits flat. We'll use the side with the holes face down in the moulding box. This has been set so that nothing touches the sides of the moulding box, and there's a space in the corner for us to complete the moulding work. We give a quick sprinkle of parting powder, and it's just used to help remove the pattern from the sand when we're opening the mould. Because the sand has oil, you may want to wear gloves to protect your hands or use a barrier cream, particularly if you're using reclaimed second-hand sand. We start off by sprinkling the sand, breaking it up as we go, just like making a rhubarb crumble topping. And we partly fill the box. We never fill it in one go. If you fill it in one go, you'll be able to form a very hard surface, but where you need the strength of the mould around the pattern will be compromised.
Right, as I said, the molding sand has to have some properties. So it shouldn't be too tight, right? If you ram it more, it will become too tight, and the gases will not be allowed to escape. If it is too loose, then the molten metal will go in through that soil, isn't it? So optimal amount of ramming is done so that that mold is intact, right?
So we just use our fingers to press the sand down to hold the pattern in place. The sand now needs to be rammed down more tightly. This is a typical ramming tool with a flat end on one side and a tapered end to get into corners. I find these are sometimes too large with the small boxes that we're using, so just a piece of broom handle with a tapered end works particularly well. The tapered end is used to get into the corners. You don't need to go crazy. It's not a competition for the world's strongest man. You just add some more layers of sand, build it up. It might take 2 or 3 layers as the sand compresses down. We now need to level off the sand, and that's just done with a piece of bar. The process is traditionally known as strickling, so the tool we use is known as a strickling bar. And if we use a sawing action and take it off a piece at a time, we end up with a nice flat firm surface. And turn things back over, and now you can see we've got the pattern surrounded by sand, and we can just run our fingers to make sure that it is firm. That won't do it any harm at all. We now take the second part of the pattern.
Right, so we just flipped it over, isn't it? Now that is done. Another part he will take, he'll put that on, and then the top cope he will put, again pour the sand, just so that we can have that pattern also covered with sand.
Pattern and locate that in place. We add the cope. We have another dusting of parting powder. This time the parting powder serves 2 processes.
Do you remember what he said earlier? Why we are putting that parting powder? Yes. he had mentioned why we are putting that parting powder, to take it easily, to take what the to take what easily. Mold, not mold actually, that pattern, right? Because we have to remove the pattern, right, before filling in the molten metal, isn't it? So you see, once we have removed the pattern, what is left there is called mold cavity. Okay, you have to remember the terminology. That thing what we are removing before pouring in the molten metal is pattern, and the cavity that will be formed is called mold cavity. Okay, so to take that pattern out easily, right, we have, because otherwise it would stick to the sand, and once you're removing the pattern, that surrounding sand which is along its periphery, that will also be removed, right, because of that sticking nature, adhesive nature. So to avoid that, we are putting that sand, so that will avoid any eroding of the sand, right, when we are removing the pattern. I hope that is clear. And he's mentioning another reason, I believe.
Firstly, to release the pattern from the sand, and also to stop the 2 layers of sand from sticking. We need to find a way to introduce the metal into the cavity of the mould. We do that by...
Right, another reason is, in between these two cope and drag, you also have this sand interface, right? So just so that they don't what do you call, mix up with each other, we have that parting sand. Another reason for putting that parting sand. 2 layers of sand should not stick, right, that is exactly the reason why we are putting that parting sand. This time it will serve 2 purposes.
by adding a runner. If we were doing a pattern which needed it, or if you were doing an educational course, you would always need to talk about having a riser, which is a second channel on the opposite side. For this particular task, we only need to have a runner. I use this tapered wooden pin known as a sprue pin, and I place it in the corner of the box. If it touches the pattern, it will damage the outcome. If it touches the flask, the heat from the molten metal will sink out and it will start to solidify before it has completed the task. We repeat the process. Mary Berry would be proud of me doing this. Pressing the sand down and using the ramming tool again to firm the sand. The ramming tool doesn't fit down into the corner, but that doesn't matter. You can use any old thing. I'm using the Strickling bar. The sand on the second box, the cope, doesn't need to be quite so firmly rammed as in the drag. We use the Strickling bar to strickle off the top the best we can, and then to remove the sprue pin we just give it a tap, twist it, and because it's tapered it releases easily out of the sand.
Right, that taper is what is given intentionally so that we can remove it easily, isn't it, as he was explaining with that cylinder. So if that is straight, then when you are removing it, that will cause a disturbance and it may lead to that sand coming off. So that taper is provided. Generally, if you observe in many products, you have a taper. So that is one of the reason why the taper is given. So that ease of casting, for the ease of casting, or for the ease of removal, okay, of the casting. So we have made a sprue here, right? I'm audible, right? Bit low, okay. Now is it okay? Okay, fine. So you see, we have made that sprue also, from which we'll pour the metal. Okay.
I'm going to use a trowel to take the top off around the pouring hole and make sure there's no loose sand which would wash into the mould. We also produce something called a pouring basin, which makes it easier to pour the metal. It gives you a larger target, but it also reduces the flow rate of the metal going into the mould, so you get less erosion of the sand as you pour.
Right, that pouring basin, right, is what is responsible for making the molten metal flow easily. Otherwise, if you pour it directly, it will come down and there will be erosion at the bottom where you have that what do you call, the L type of portion, right, from the sprue to the other part of the gating system. So to avoid that, we are giving this pouring basin. So you'll pour it here and it will slowly come down through the sprue. So that is responsible for
Good practice is to add some vent holes just by pressing in a piece of wire, which allows any air to escape and any small amount of smoke that may be produced by the oil burning out. And we can split the two halves of the flask. The patterns now need to be taken out. That can be done just by giving them a gentle tap and then lifting the pattern cleanly out. We've got a good impression in the sand. The same with the other half. That's come out quite well. There's a little bit of looseness there. Nothing to worry about. That can.
Right, if you observe, he gave a little tap, right, just so that the dimensions of that cavity would increase a little bit, right, isn't it? That's common sense. So you see, when we are deciding the size of that pattern, that allowance has to be there, isn't it? Just so that you know that to have it removed easily, we have to give a tap, and that tap will kind of increase the dimensions. So that allowance has to be given, that you will make this pattern a little small, right, for it to have this kind of allowance, right? So there are several allowances that are given. We'll see what are the type of allowances, but just so you have an idea that the pattern is not exactly made as per the casting dimensions, okay, as per the cast as per the dimensions of the casted object. It is either made a little smaller or larger, right, based on all these allowances. So we have shrinkage allowance also, right, we'll see all these allowances. So we have to take all that into account so that the pattern size can be decided, okay, so that your final part is as per your design specifications, right, considering all these problems, okay, of shrinkage and this ramming that we are doing, and there are many other allowances, okay. I hope that is clear. Any doubts so far? Okay.
Be repaired by hand. We can see there's a small impression on the sand left by the sprue pin. That gives us a good indication of where we cut a small bowl. The final piece of moulding work we need to do is to cut a gate. We know what a gate is. It's where you go into something, working away from the mould cavity, and we need to ensure that there is no loose sand. A good way of doing that is to blow.
So that sprue cavity what we made, right, that will go into that cavity that he made, and then through that gate it will enter the mold cavity, right?